Hello, I'm Josh Rosenthal, an AWS Product Manager for the AWS Certificate Manager and Private Certificate Authority services. Today, I'm going to be talking to you about Enterprise SSL TLS certificate issuance and management utilizing AWS Certificate Manager and the Private Certificate Authority services. I wanted to start by sharing with you a goal we've heard from a number of customers. They've come to us and said, I have people across my organization who need to encrypt connections and identify resources using SSL TLS certificates. They have websites, applications, load balancers, APIs, service meshes, custom applications that they built, and a range of other solutions that they need to interconnect in a secure manner and be able to have identity associated with each of those endpoints. They're experts in those services. They understand how they work, but what they don't understand is how to build a framework that allows them to interconnect in a secure manner. The idea of public key infrastructure, PKI, was designed to allow that communication. And there's an entire framework of certificate authorities, CAs, certificates that are issued from those certificate authorities, and trust that enable that secure communication. What we're going to show today is how to quickly and easily set up that PKI infrastructure and a CA hierarchy so you can get to the business of establishing those SSL TLS connections between your services. When you're done with this tech talk, you'll be able to create your own certificate authority in the Private Certificate Authority service. We're going to walk through how to put strong identity and access management, IAM, protections around that certificate authority, as well as how to monitor and audit the certificate authority. We're going to look at how to issue certificates from the CA, how to use the AWS Certificate Manager service to issue private certificates that are automatically renewed. And then lastly, we're going to look at assigning a certificate to AWS Elastic Load Balancer, ELB, to show you the final step to this process of putting those certificates in place. We'll walk through each of those steps. I'm going to start by describing two of the important solution components. Then I'm going to do a demo on how to build and secure a certificate authority. I'm going to walk through the policy around CA security. Then we'll walk through a demonstration of sharing a certificate authority, another demonstration on how to request a managed certificate from TLS from the account that the CA was shared to, associate that with the ELB, and then some frequently asked questions from our customers, and a conclusion. The first component I want to talk about is AWS Certificate Manager. The Certificate Manager will enable you to issue a certificate, and it will handle the life cycle of that certificate. Certificates have a duration that they're good for. When issued from ACM, that duration is 13 months. And at 11 months, ACM will automatically issue a new certificate called a renewal to replace the old certificate. It will then take that certificate and associate it with the resource that was using the certificate so that you have a new certificate that's now valid for another 13 months. This ensures that you don't have a termination of service at any point due to your certificate expiring. A second core service for this solution is the Private Certificate Authority. The Private Certificate Authority allows you to issue certificates that are trusted within your organization. You will be able to issue to any domain or IP address that you need, and certificates of any type, or key size. This can be done in integration with AWS Certificate Manager, what we're going to demo today, but you can also manage the private CA and access it through APIs, the CLI, or through CloudFormation templates. One of the important features we'll be talking about today of the ACM Private Certificate Authority is CA sharing. CA sharing is where you create a certificate authority in account one, say a security account, and then you share it to all of the customers in your organization who need access to that certificate authority so that they can issue certificates. As an example, we have a customer that I worked closely with that has employees across the world that need access to their certificate authority. Because of that, they wanted to be able to create one centralized account that the security team managed, but each of those other individuals had their own account with their own usage. They wanted to be able to request certificates from that trusted CA, and this service and feature will allow them to do that.
Another important component in this solution is AWS Resource Access Manager, RAM. RAM is used to share resources across your environment, whether it be to another account or to AWS organizations. RAM makes it easy for you to take the resources that you need and make them available to other accounts via their console or through CloudFormation. The way RAM works is you start by creating a resource share. This defines the set of resources that you want to share across your organization. You take the resources and insert them into that resource share. Then you're going to define your principals. A principal is an account or an AWS organization. An AWS organization can either represent everybody within your company, or you can have multiple organizations broken up by specific areas of operation. That way, for this example, when you're sharing a CA, if you wanted to share one specific CA to your development team so that they could do development, you would share it to the development organization. If you were sharing a different one to the marketing team so that they could push out certificates for your websites, you would share to the marketing organization. And then there might be a third CA that's only used by your security team. So you share that to specific individuals in the security team so that you can follow least privilege. Once you've added the specific principals for the specific resources, you're going to click Share. At that point, all of the resources are shared to those individuals, and it's as easy as that. We're going to walk through the RAM console later, and you're going to see how you can share these resources across the organization and how well it integrates with Private Certificate Authority.
As I'm talking about the people behind it, I'm going to use some reference names as we go through this, and I wanted to familiarize you with them. These are names that are typically used when talking about cryptography and PKI, so they might be familiar to you. The first person is Alice. Alice is the certificate administrator, which means she manages the certificate authority. We're going to start with her account, and she's going to create a CA as the first step. Next, we have Bob. Bob wants to create certificates so that Bob can
enable TLS.
He's responsible for configuring secure network transactions. Bob's in a totally separate account than Alice, so Bob's going to need Alice to share the CA with him. Shayu is also a CA issuer. She also configures secure network transactions and has a similar job to Bob and needs the same capabilities that he does. Lastly, we have Danielle. Danielle works closely with Alice as a CA administrator. She manages the CA and is responsible for working with Alice to ensure the security of that CA. What we have here is an example of Alice, Bob, Shayu, and Danielle's organization. They're all located within a single region inside of AWS. And we'll start with the account that Alice and Danielle have, where they're going to create a private CA, and then they're going to use AWS Resource Access Manager to share that CA with other people in the organization. For example, Bob, who's going to need to issue a certificate off of the Certificate Manager to ELB, Alice can share the CA to Bob's account directly utilizing AWS RAM. As another option, you can have an AWS organization, which defines a group of accounts so that as opposed to just sharing with Bob, Alice could have shared the CA with the entire organization, which would include both Bob and Shayu. Now that you've seen the structure of the sharing we're going to do and you understand the components that make it up, let's go into a demo of creating a CA. As you can see here, this is an account that Alice would use. And we're going to go into the Certificate Manager. And here in the Certificate Manager console, Alice wants to manage her private CAs. As you can see, Alice already has a root. A root CA is the core of trust to an organization. And keeping security to that root is very important because it is what defines the identity of any machine that a certificate is issued to in the organization, as well as allows that secure communication because it's trusted. So taking care of and keeping protections around the root's important, and we're going to talk to that. Right now, though, Alice wants to create a subordinate issuing CA for Bob and Shayu to use. So Alice is going to start by creating a CA. As we talked about, Alice is going to create a subordinate CA. So in this case, we're going to declare Alice's, a common name for this CA, Alice's subordinate. You don't have to fill in all of these fields. You only have to fill in one of them. So for today, we're just going to fill in the common name. The rest of these fields help you define the CA and the details and usage of it. We're going to use an RSA 2048-bit key as standard. You can choose other key types and key sizes, but there's no need to do so here. Certificate revocation is when you need to revoke or end the life of a certificate immediately, often because the keys of that certificate have been compromised or because the device or service that was associated with that certificate is no longer active. We're going to enable certificate revocation list distribution. We're going to create a new bucket. In this case, we're going to call it Alice's subordinate bucket. We aren't going to add any tags today, though tags are very useful for tag-based authentication of the certificate authority when you're dealing with multiple certificate authorities. And lastly, we're going to enable ACM to be able to renew certificates issued from the CA. This is very important because we want the certificates that are issued to be renewed automatically by ACM. We can then check all of the data, click to confirm, and then we confirm and create. And successful. Our CA has now been created. There's a second step though. I need to install a certificate into the CA, and that's what identifies the CA and represents the public-private key pair of which the private key is used to sign each of the new certificates. So I'm going to choose Alice's root CA, which is available there. I want to set a validity of 3 years for the certificate authority and a path length of 0, which means that no CAs will be able to be created off of this subordinate CA. I can then check all of this information and click Generate. And I now have Alice's subordinate fully created and ready to be used. That's all it takes to stand up a certificate authority inside of the Private Certificate Authority service. I mentioned after we created the CA, we'd talk a little bit about putting permissions in place. This is a set of IAM permissions which a number of our customers have put on root certificate authorities to enable two-person access. Two-person access is when you need two individuals to be able to utilize a root CA, and that one person alone would not be able to utilize the service. In this case, what we've done is we've broken up the roles. This specific IAM policy is for Alice, and it is going to allow Alice to issue certificates, and specifically CA certificates, off of the private CA root. This means that Alice can create subordinate CAs, but Alice cannot, she is denied the ability to update the certificate authority. That's important because one of the features of Update Certificate Authority is disable and enable, so that when a CA is disabled, no one is allowed to issue off of it, only once it has been enabled again. So by preventing Alice, denying her the ability to update the certificate authority, Alice cannot act without a second person, in this case Danielle, to enable the certificate authority for her. And only once Danielle has acted would Alice be able to issue a certificate. Here are Danielle's policies. Notice Danielle is explicitly denied the ability to issue certificates, but she can update the certificate authority. This means that Danielle is allowed to turn the certificate authority on and off, enable and disable, but can't actually issue a certificate. So by working together, Danielle can turn on the certificate authority, Alice can issue a certificate, and then Danielle disables it again. This two-person access ensures that it requires a pair to utilize the certificate authority. This exact set of permissions are utilized by a number of our customers who want to lock down their root CA and ensure that it requires at least two individuals to be able to issue CA certificates off of their root. Another important factor for CA security is being aware of what is going on with the CA. The 4 API calls here, create certificate authority, issue certificate, revoke certificate, and create certificate authority audit report, can trigger CloudWatch events. You can subscribe to these events so that you are alerted at any time an individual creates a new certificate authority, or revokes a certificate. This is an important aspect of security so that if an action is taken, you can quickly remediate that action, as well as be aware of all of the activities that is going on in your organization. A third security precaution is the private CA audit report. Every time a certificate is issued, an entry is added to the private CA audit report. That way, you can review the audit report and see all of the certificates ever issued by that CA. The certificates will be in this form with the account ID of the issuer, the ARN of the certificate, serial number of the certificate, subject the dates it is valid for, and then the specific type of certificate, the template that was issued. Reviewing your audit report is an important way to keep security for your certificate authority, because you will be aware of exactly what happened and be able to detect if a certificate was erroneously issued and therefore revoke it. You've now seen how to create a certificate authority, how to protect that certificate authority. Let's look at how to share a certificate authority. Here we are back at Alice's account with Alice's subordinate that she wants to share. So we're going to go from the private CA console to manage resource shares. This is going to bring us to the Resource Access Manager console and allow us to create a resource share for Alice. So we clicked on create a resource share. Now we're going to create a name. So Alice's subordinate. We're going to select a resource type, in this case, a private CA. Alex has 2 CAs that she can share. We want to share the subordinate. We don't want anyone issuing off of the root. Now, we're able to share either to an organization or a specific account. For this demonstration, we're going to share to a specific account. And we're going to share to Bob's account. We don't need any tags, so we're going to create a resource share. Alice has now shared that certificate authority to Bob. We're mostly done, but there's another step. When you share a resource to another account, that account needs to accept the share. So let's go to Bob's account. Now we're in the AWS RAM console in Bob's account. Notice Bob has an invitation waiting for him. So Bob clicks on Resource Shares, and there Bob can see that Alice's subordinate is waiting for him to accept. By clicking on Alice's subordinate, he can accept the resource share. This is going to allow him to utilize that CA for issuing certificates in his account. I really do want to accept the resource share, and it's now active. What Bob can do next is Bob can go to Certificate Manager. And if Bob looks in the private CA screen, Bob will notice that Alice's subordinate is now available and that it was shared by Alice. Now that we've shared Alice's CA with Bob, Bob is going to utilize that CA to request a managed certificate for TLS. Here we are back at Bob's account, and now Bob's going to go into the Certificate Manager. Bob would like to get started and issue a certificate. He wants to use a private certificate because he's requesting it from Alice's CA. And here, he'll be able to see the specific CA that was shared with him. If there are multiple CAs shared, they would be listed as well. But in Bob's case, it's just the one CA. Bob is going to issue a certificate for the valid domain name he wants to use. And because it's a private certificate, it does not have to be a publicly verified domain. It can be any domain that's used inside of his organization. He could also add multiple domains to a certificate. Bob's not going to be using tags today. And we can review the information that we're issuing off of Alice's subordinate, this domain. We're now going to request the certificate. And there we go. Bob now has a certificate issued off of Alice's CA. And here's all of the details about that certificate. When it was issued, the algorithm used, the CA it was issued off of, so that Bob can look at that certificate and get details. As you can see, it's not yet in use. So let's fix that. Now we're going to go to EC2, where Bob is going to create an elastic load balancer that he can associate this certificate to. So in the EC2 console, we go to Load Balancers. So Bob will create a load balancer by clicking Create, and he's going to create a network load balancer. Bob's going to start configuring his load balancer by giving it a name. It's going to be internal facing, and it's going to use TLS. We need to choose some availability zones, and we'll choose all the availability zones just to make sure that the service is available. Next, we want to configure the security settings. As you can see, we've already requested a certificate from ACM because that was chosen as default, and the certificate we issued is already made available. Next, we want to configure routing to a new target group, Bob's target, utilizing TLS. We're not going to set up any specific instances right now, but we're going to finish setting up the load balancer and click Create. You can now see that Bob's load balancer was successfully created utilizing the private certificate that Bob issued. And we've finished configuring the entire infrastructure where a CA was created by Alice, the CA was shared to Bob. Bob then used that CA to issue a private certificate and associated it for TLS. Here we are looking at that account structure again. And we can see how Alice created a CA, Alice and Danielle locked that CA down and put appropriate security precautions around it. She then shared that CA with Bob, or had she wanted to share with the organization, Bob and Shayu. Then Bob used ACM to issue a certificate and associated it with an elastic load balancer. Had Bob wanted to use that private certificate outside of an AWS resource, Bob could have exported the certificate. And when he did so, he would have received a notification when the certificate was ready for rotation via CloudWatch events that the certificate had been renewed, and he could set up automation to send that newly renewed certificate to its external endpoints. There are 4 common questions that we hear from customers about certificate management and CA management. And the first one is, how do I manage certificate trust? I referenced certificate trust earlier when we were talking about a root CA. That root CA represents trust across the organization, and in order for browsers or applications or servers to trust a certificate that was issued by that root, you need to take the root CA certificate and load that into the endpoints. This can be done via operating system tools like in Windows or Mac OS or Linux. It can be done as part of building an application or a service. It's very easy to query the private CA to request the CA certificate and then use that to load it in for trust across your organization. It's important when building a private certificate authority hierarchy within your organization that you think about how you're going to push trust out and how you're going to manage trust. A second question that we get is around certificate renewal and making sure that their environment is able to renew the certificates and that services aren't terminated due to certificate expiry. AWS Certificate Manager, by automating the certificate renewal process, allows customers to either automatically have the certificate issued and then installed into their AWS services, or for those services not directly integrated with ACM, to receive a CloudWatch event that will notify them that the certificate's been renewed, so they can automate that and push the certificate out to the endpoint. This allows for an automated process around renewal and ensures that you don't lose service operations due to certificate expiry. Similar to certificate renewal is CA renewal. That may seem like a long way off. If you remember, when we created Alice's subordinate CA, that was a 3-year duration. So that's the you 3 years from now that has to worry about it. However, the you from 3 years from now is going to care a lot about knowing that a CA is due to expire, and that same you from 3 years ago might actually be someone else's from 3 years ago who created a CA in your environment that now needs to be rotated. There are two aspects of that to take into account that can be supported by the private CA service. The first thing is that with all of the CAs being available from the console and from a centralized account that you share, it makes it very easy to manage and view the status of all of your CAs. Secondly, by building a hierarchy with a long-lived root CA, 10 years or 20 years, you can rotate the subordinate CAs without having to rotate trust. That way, as we talked about, the management of trust doesn't need to be updated until you update the root of the hierarchy. That simplifies things and makes CA rotation easier. Lastly, a number of customers have asked us about whether or not they should stand up a unique CA for every solution, or if it's appropriate to use a CA for multiple solutions. And the answer to that varies, but generally, you can utilize one CA for multiple solutions as long as the ownership of those solutions remains the same. If they are different departments within your organization or they are different regions, that's the time that you might consider having multiple CAs so that you can separate the chain of trust and the chain of management. For example, if you have certificates that enable trust within your HR organization, you might not want to allow your developers to issue certificates off of that CA. In conclusion, our customers started with the issue of how do they stand up a PKI, manage it, secure it, issue certificates, and then enable TLS within their organization. You now have the skills to utilize these different AWS components to accomplish all of those goals so that you can set up TLS quickly, easily, and securely within your organization.
To get started, there are a couple of actions that you can take to understand if this solution is going to work for your organization. The first thing to look into is what your organization is doing today for its current PKI. It may be that other members of your organization have already stood up a private CA in the company, and that you can utilize that for the use cases that you have. It may be that you have an on-premises CA and that a cloud CA for use with your cloud resources could be added to that CA hierarchy, or it might even make sense to replace that CA hierarchy with one in the cloud. By investigating your current hierarchy and your organization's current PKI, you'll know what you have to work with and be able to coordinate with the individuals who own that in your organization. Don't be surprised if you find out you don't have a PKI today, and there are people in the company who have just been using self-signed certificates. That's a great time to invest in building a PKI so that you can manage trust across the organization, as opposed to managing the trust of individual certificates that can lead to outages. To try out the AWS Private CA, you can create one, and it is a free trial for 30 days. That way you'll be able to create the CA, look at how to update it, look at how to share it across your organization, and utilize ACM to issue certificates. All of those are included in the free trial. If you choose to export certificates either out of ACM or you issue a certificate directly from the private CA via the private CA APIs, then you would incur a certificate cost. But as long as you're utilizing ACM to issue the certificates and associating those certificates through ACM, as you saw earlier, with AWS resources, there's no charge for the certificate issuance or the CA for that first 30 days. And in fact, for ACM, there's no charge afterwards for any certificate that is generated by ACM and used across your organization. Charges may apply for resources that you create inside of AWS that you associate the certificates to, so be aware as you're doing your investigations. Another great place to get started, once you have a certificate authority created, is the RAM console, or RAM via CloudFormation, their CLI or API. Utilizing RAM to look at how you could share, how to configure sharing, and how to monitor sharing in your organization will make it easy for you to perform management ongoing. One of the nice things about setting up AWS organizations is that it dynamically handles as new members are added to the organization, and therefore you don't have to share the CA to new individuals along the way. You just have to add them to the organization. Lastly, and I was referring to this as part of setting up the free trial private CA, utilize ACM to issue a certificate. If you're issuing a private certificate, there is no domain validation, so it's very easy to do. There's no cost involved unless you try and export that certificate outside of ACM, and it will allow you to try out the whole process. These are 4 ways that you can get started and try out what you've seen today and look at how it might work within your organization.
If you need more information or are looking for a place to get started, here's some resources that can be helpful. The AWS blog on utilizing RAM to share your ACM Private CA across accounts, the Private CA sharing documentation that describes how to share a CA, the Private CA service pages, the ACM service pages, and the RAM service pages. These will provide you with a set of steps on how to set up your CA, share your CA, secure your CA, and will add additional references and capabilities beyond what I demonstrated for you today. I hope you enjoy getting started setting up TLS within your environment, and thank you very much for listening.